So yesterday we talked about area and perimeter of different types of shapes. And I had a really good question, and it was about, does the area and the perimeter, is one always bigger than the other? So I'm going to show you a picture and describe why there's no consistency there. So in elementary school, when you learned about area, you would have been given square tiles, and you would have been told to cover a certain space. And then in order to find the area, you would have had to count the tiles. So for this particular picture, I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So it's 25 of these units that are squared, and it's these units, tiles. So if you say, how much do I need to cover this? I would need 25 tiles. The perimeter, on the other hand, is like going around the edge. 1, 2, 3, 4, 5, where one unit is from here to here. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And these are just units. The difference here is the difference between a starburst and a piece of licorice. If you asked me for 5 starbursts and I gave you 5 little pieces of licorice, you would be disappointed. So to say that these are only 5 units apart, it's not accurate. They're 5 numbers apart. 25 and 20 are 5 different in number. But when I'm talking about square units versus a linear unit, we're not even talking about the same thing. So for you to say, again, trying to compare a starburst, because that's what these looks like to me, 25 starbursts versus 20 little tiny pieces of licorice, they are not the same units. So I am pretty particular about writing my units, showing which ones are squared or tiles or starbursts versus those that are linear, to try to help us understand the real difference, the fundamental difference between area and perimeter. Okay, our notes for today. We're going to do more area and perimeter, but we are going to be graphing these coordinates and then solving from there. So this is, none of it's new. This is taking pieces of things that we know and putting them together. I'm noticing that some people are having a hard time graphing a point. And I think it's because we've done slope, 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 more slope, slope again, slope again. And now we're going back to graphing a point, and we keep thinking rise over run. All right, that's not what we're doing. So the first number in ordered pair is your x value. And on the x-axis, it tells you how far to go left or right. Left if it's negative, right if it's positive. The next value represents your y, or vertical, up and down. How far up will I go? How far down will I go to get this point? So they say that the gentleman who, I'm having a hard time remembering his name, Cortez maybe, a mathematician, he was ill. He was not a well man. And he lived in this beautiful English home, and his ceiling was tiled, kind of like the schools, but I imagine his being wood and painted and maybe gold embossed, something fabulous. So looking at this graph, that's what his ceiling would look like. And there was a fly that was flying around, and it kept landing and landing. And he thought to himself, because he was a mathematician, how could I describe to somebody the exact place where this fly landed in the simplest way possible? And he came up with this coordinate grid. So as long as you understand how it works, we're all going to be putting points in the same spot. So I just put A and B. So for C, since they're both positive, I'm going right. 5, up, 3. Not rise over run. Please don't do that for ordered pairs. And then D is a negative 1, so left 1, up 3. It looks like I plotted that one wrong. Left 1, down 4. Okay, so I've created a rectangle here. You can connect them if you want and count as you go maybe. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Perimeter is adding up. Side plus side plus side plus side. So for this one, it's 6 plus 7 plus 6 plus 7. And yes, they're shortcuts. Most kids don't like them. So 26 units around, 26 little bits of licorice. Since this is a rectangle, the area is base times height. So the numbers for this one are 6 times 7. Area is 42. And again, these are square units. These are starbursts. Okay, that's the gist of this work. You've got to plot the points properly, count 1, 2, 3, 4, 5, 6 very carefully. If you count wrong, you're going to get the wrong perimeter and the wrong area. So be careful on the plotting and the counting. It might not seem as important, but if you do those incorrect, you will not be getting the right answers. Okay, push pause, go and graph these on your own, and then unpause and make sure you're in the right spot. All right, so I've got 1, 2, 3, 4, 5. Oh, this is the one I just did a second ago. The explanation. All right, perimeter, we add all the outsides. 5 plus 5 plus 5 plus 5. Area is base times height. Or since it's a square, it's side squared. Same thing. These are starbursts. Okay, I'm skipping that one for now. Going down, we can see that there's only 3 coordinates, so this is not going to be a quadrilateral. This will be some type of a triangle. Again, push pause, plot these 2 points, come back, see if ours match. All right, as I'm looking at this though, I can't count all the way around. 1, 2, 3, 4, 5. I can count there. 1, 2, 3, 4, 5, 6. I can count there, but I do not know the long side. And I can't count because they're diagonal units. So I can use the Pythagorean theorem. And I don't really know where to put it because it's not helping me find the perimeter. A squared plus B squared equals C squared. That's our Pythagorean theorem. And we don't know the hypotenuse, but we do know the legs. So go ahead and push pause and solve this. You should be squaring, adding, square rooting. This is the step that some people get confused on. Okay, now that I found 7.8, I can use it. I don't need it for the area, actually, but I do need it for the perimeter. Adding up all the outside values gives me 18.8 units. This is our perimeter. Now, this is a triangle. It has a slightly different area formula. An area of a triangle is 1/2 the base times the height. So in this case, 1/2, 6 times 5. 6 times 5 is 30, and half of that is 15. These are square units. This is my area. So as a reminder where that comes from, see if I can get rid of some of this stuff on my picture. If I extend this rectangle, like if I make a copy of it and lay it up over its side, okay, I've got 2 identical triangles. If I did base times height here, I would get the area of the entire rectangle, but that's not what I'm needing. I'm just needing the triangle. That is where the 1/2 comes in. And again, if I told you to get starbursts, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there would be 30. There would be 30, but we don't need this part. We just need the triangle. So half of those 30 starbursts, or area, is the 15 square units. Okay, the reason I'm skipping this one is because, well, we're not covering something quite this difficult. So I'll just kind of show you what it looks like. We've got this rhombus, which is just a square. It's a square tipping over. So it's hard since it's tipped over because I can't count that side. It doesn't work that way. Oh, that's what I pushed last time. Oh, I pushed that button last time that creates a new page, and I couldn't figure out what I'd done. I'm not tall enough to reach that arrow, I guess. Okay, I don't even dare try that again. Oh, there we go. I can't find that area by counting. I can picture 1, 2, 3, 4. 1, 2, 3, 4. I can create these right triangles. All the way around, they're going to be the same thing, but I just need to do one. Since this is a square, if I find this hypotenuse, I will know all of them. So I know the legs of this right triangle. I'm trying to find C. Kind of the tricky part, finding that square root of the 32. Okay, we are not done. That is not the perimeter. It's C. Oops. All right, so in order to find the perimeter, I do 5.7 plus 5.7 plus 5.7 plus 5.7, all the way around. And it is just a square, so my base and my height, I can tip it sideways and do 5.7 times 5.7. That's my area. Still a square, it's just tipped, so we had to do a little bit of work to find the length of the side. Okay, so before we go into the back, let's review what we've talked about here. Be very, very careful where you plot your points. In fact, during the homework, I was asking the kids to peek over at their neighbors and make sure that their picture looked the same, especially if they messed up multiple times here on the notes. So be very diligent. The second thing we do is we count the sides that are flat on the grid, so we can find some of these dimensions. The base and the height seem to be very important. It also helps to write all 4 numbers around the edges, or sometimes kids forget on the perimeter and they'll just add 2 of them. So be careful with that. Add all the way around so your animals don't escape your fence. Excuse me. And when you have a triangle and you cannot count the diagonal distance, the method for finding it is the Pythagorean theorem. A squared plus b squared equals c squared, where where c is the hypotenuse and a and b are the legs. And remember, we call them legs because they touch that right angle, and we call it a hypotenuse because it does not touch the right angle. It is across from the right angle. And we do have a formula sheet that you can go look at. In fact, that might be very helpful to go look at your formula sheet if you're forgetting maybe triangle. Maybe you've got to triangle and are like, oh. Okay, turn your whole entire note packet over. It's not even the back of this page. It's the back of the entire packet. So as a review, we've got y equals and x equals. And we've been plotting points, and now we need to review how to plot these lines. So ahoy there, me mateys. Vox, which sounds like fox, but not quite. So if you have a y equals something, you're going to focus on this one, hoy. This H stands for horizontal on y. So I go to where y equals -1, one place. So this is what my eyes are looking at right now. My eyes are looking here. And I'm going to go to -1. That's where y equals -1. But y actually equals -1 all the way across. So that's where this H, horizontal on y. Same thing on the next one. Go to where y equals 4. Go to one spot. Horizontal. All of these represent places where y is 4 also. X is changing, but y is always 4 up there. Okay, let's focus on the next ones. Vox. This V stands for vertical on X. So let's go find X equals -1, and my eyes are going right here. Hey, I want yellow. My eyes are looking here to remember where the X is. and I'm going to -1. Vertical. So I think of like your vertebrae on your back. Unless you have scoliosis, those ought to be straight. And horizontal, I think of the horizon. Those are the same root words. Okay, back to this one. X equals 4. I'm looking at my X. I'm going to 4. This is a vertical on X. Okay, any questions? That's funny. You can't even ask me anything. Well, what am I finding here? Are we doing tic-tac-toe? No. We are still finding the area. We're finding the area of this part. So we count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We actually did the same shape on the other side. 5 plus 5 plus 5 plus 5 is 20. And 5 times 5, base times height, is my area. So you get the gist. If I'm going too fast, please pause this. Pretty please. Okay, x equals -2. I am looking at x. I'm going to -2. Box vertical on x. X again is 4. Vertical on x. Switch colors for fun. Hoi! Horizontal on y. And up to 5. Ginormous. Now I count. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now I know on your notes these are blurry, really light. Maybe that's a better word. It did not print very dark, so be careful when you're counting. Like if you have to come and look at your numbers over here, you could. Like from 6 to negative, like that's 11 apart. These are 6 apart. You can double check. Okay, perimeter. 11 plus 6 plus 11 plus 6. My area is base times height. These are square units. These are starbursts. Okay, looking at the last two, clearly they are triangles. I've got 3 vertices, or 3 lines. So let's practice these ones. Ahoy there, me matey. Horizontal on y. I've got a 6 on it, but I'm looking at this y. Horizontal, like the horizon. Box. Vertical on x. Looking at x. Making a vertical line. Pretty good triangle so far, but I've got to do something diagonal. So that's where we get into this. Y equals -x. Sometimes it helps to put that. So it goes through the origin. And the slope is rise 1, run -1. Oh, I got off one. That's hard to draw. Maybe use a ruler, because when you count, you want to be very perfect. 1, 2, 3, 4. 1, 2, 3, 4, 5. Does that look right? Yes. Oh, I don't know. I think I started at -1. 1, 2, 3, 4. That was not very perfect. Okay, now that we've got these two sides, 4s and 4s, actually, 4 and 4, that's what we had over here. And we already used the Pythagorean theorem and found that it was 5.7. That's a nice shortcut. Use the Pythagorean theorem. 4 squared plus 4 squared equals c squared. And we just happen to have these same dimensions on the other side, so not that bad. Now we add them together. Sorry, I did this wrong on my notes page, so it's not matching what I'm doing right here. I just wanted to make sure. Well, this might be wrong then. I'm a little nervous. So 5 plus 4, 5.7 plus 4 plus 4. This is my perimeter, and it's a triangle. 1/2 base times height. So 4 times 4 is 16, and half of that is 8. That's my area. Okay, well, hopefully that's not wrong. I had a 3 right here on my notes. I wasn't using a ruler, so it's very likely that I messed up on one of these two. Okay, so this one is the last one we'll do, and then you can work on that homework. So ahoy there, me mateys. Horizontal on y. I'm finding my y. I'm going to -1. I'm drawing as straight of a horizontal line as I can. Please use a ruler. Vertical on x. I'm looking at x. I'm finding the 1. I'm making a vertical line. Now the diagonal one. The y-intercept is a +5. The slope is -2. I might want to put it over 1. Rise -2, run 1. Rise -2, run 1. So I've got a 2 by 4, it looks like. 1, 2, 1, 2, 3, 4. Let's use the Pythagorean theorem. A squared plus b squared equals c squared. I don't know c, but I know 4 and 2. This is kind of a new part, the inverse operation of taking the square root. The square root of 24, I got 4.47, and I rounded here a little bit. I like to write it on my picture. So let's add these up. 4 plus 4.7 plus 2. This is the perimeter. It's all adding up those 3 values. Adding up 2 plus 4 plus 4.47. And 1/2 base times height. 4 times 4 is 8. Half of 8 is 4. These are square units. Okay, good luck with the homework.